Firstly, the session will take about 60 minutes to complete, but of course it will be recorded for those of you who won't be able to attend for the entire time, or should you wish to re-watch it later. We do welcome any questions, and you can just unmute yourself at any time. You can also use the chat function to post questions and comments as we go along. So for those of you who don't know, Bobby is leading the R team, who is behind the Foundations of Data Science course and the Communication and Visualization program. And he holds a PhD in Advanced Quantitative Methods from the University of Bristol in the UK. So before joining us in 2019, he worked as a data scientist and educator, most notably at the university, where he set up a data science support service for researchers who are working with complex data or modeling problems. So thanks, Bobby. We can get started.
Thank you, Mallory, and also thanks everyone for coming. I'm really excited to see so many faces. A lot of you already familiar, some new ones. But yeah, thank you all for joining. I'd also want to, thanks Mallory for the introduction. I also want to quickly introduce my colleague Enrico, who is also here. He just logged on, and he's also a teacher. So some of you might have met him already in one of the one-on-ones or when a question was answered on the platform. He will be fielding any questions you may have about what we're doing here while the session is running. You can put your questions in the chat and Enrico will take care of them. I believe we also have Daniel. Daniel is also a teacher at our team. He's also on board. Some of you will know him too. And yeah, and we have from our team, we have from the wider extension school, we have some other colleagues joining here as well. Thank you for that. So let's get started. We have an hour. I aim to finish the active part in about 45 minutes, famous last words, so that there's a bit of time for an open Q&A at the end. If you want to code along, I'm going to point you now to a GitHub repository that you would have to download onto your computer, because it contains the files that you need. So I will paste a link in the chat. And if you follow that link, it will take you to the GitHub repository. Now, if you don't know how to download a GitHub repository, I'll share my screen and show you. If you do, by all means, go ahead, download it, put it in a folder that suits you and your machine, and then we can start it. So if you don't know how to download the GitHub repository, I've just opened up the link in my own screen. Top right, above the list of files, you can see that there's a green code button. If you press that, you get a couple of options, and the bottom one is download zip. And that means that you'll download the whole repository as a zip archive to a location that you choose, or to your downloads folder, whatever the setting on your computer. So please do that now if you want to code along. If you weren't anticipating coding along or want to eat your lunch while we're doing this webinar, absolutely no problem. I will show all the code myself. It's not required to code along. And in fact, this repository also contains the answers already. So it's really more for you to if you like to be interactive, if you like to kind of feel how this code is developed, then you can join along. Now, I'm assuming that everyone's got the folder downloaded. Make sure that on your computer, you've also unzipped it. So for example, in my case, I have it here. It's a folder called EXTS Learning Lab. Now go into that folder, and then you want to open the R project file. So it's EXTS Learning Lab R project. So if we open that, RStudio will open with an empty screen. And that's exactly what you need. You then go to files, and then you can open the learner.rmd file. This is the file that we will be using to code with. I don't have any slides. You'll just see my console for the rest of this webinar. Okay. If you experience any problems along the way, please feel free to mention it in the chat. But assuming everything is okay, and Enrico, feel free to interrupt me if we are stuck on something. I won't be looking at the chat myself. Okay. Now, assuming you've all done that, a little bit of background. So what I aim to show you here is a little bit more advanced data wrangling that we expect you to do at the very end of the Foundations of Data Science course. If you've just started, some of this might be a bit alien to you, but I like to focus not just on the code, but also on the kind of thinking that's behind it. It will give you some insight in what the data science pipeline is. Enrico? Sorry, you're muted, so I'm not sure if I understood. Ah, okay. Mallory, could you unmute Enrico? You can now? You're good?
Now I can, yes, perfect.
Okay, thank you. All right. So the topic of today is, are Roger Federer and Serena Williams the all-time best tennis players? And in this webinar, we're going to use data from the WTP and the ATP to answer this question. To be completely honest with you, the actual question I am asking in the approach that I'm taking is, who are the best tennis players of all time? We put a closed question on the top because it's a bit of a journalist trick. It attracts attention because it's interesting, and often people have a kind of like personal opinion about these athletes. But actually, from a work perspective, it's much more sensible to ask an open question, because we'll have to do exactly the same data processing steps, but because we're not going to answer with a yes or a no, you'll get a lot more comprehensive insights out of this question with exactly the same amount of effort. Like any question in any context, but especially also in data science, we'll have to kind of set a scope. We can't just go out and answer this question. There's some definitions needed. We need to kind of pin down what our approach is able to answer and what our approach is not able to answer. So the first thing to say is, I'm going to limit this question to each gender separately. We're not going to compare between genders. That would be quite complicated because they generally don't really compete against each other. So how do you define then who's better? And the other thing is it even of interest if there's no competition between the two genders? Then the other thing that we do is we will define whether someone is good at tennis or not by their performance on Grand Slam single tournaments. I know there's also tennis ranking lists. There's many ways we can evaluate tennis players' performance. But for time and other resource constraints, we have to kind of narrow this down. And again, this is often something we do in data science. We have to kind of be very clear on what we understand to be the best tennis player. And in this case, we will just be looking at who won each and every final of Grand Slam single tournaments. This question is still rather broad. What are we gonna exactly look at to figure out who's the best tennis player? The first thing we're gonna ask is who won the most Grand Slam tournaments? And the second question we'll ask is, who won the most Grand Slam tournaments consecutively? Now, and here a little segue into what we do in FDS. If you're already in your Foundations of Data Science projects, this might be a familiar question. It's a question that we know a lot of learners struggle with. And to be honest, that's the reason why we decided to do this webinar on this particular topic. In the final report, in the Olympics data, at some point you have to figure out who won gold medals consecutively. And we get, very often we get questions for this, on this. So if that's something you are stuck with, this second question is going to show you exactly how to do it, just on a different data set. So you might be able to take some of this away to your Foundations of Data Science work too. Now back to the tennis. When we found an answer to these questions, we can combine this information to give a comprehensive answer to our main question. Now, have a little look in the repository. In the Files tab, you can see the learner file, you can see the answers file, and there's also a folder called data. This is the data that we will be using. And actually, it's a pre-processed data set of an open data repository that is maintained by a person called Jeff Sackman. He's very, very precise. He keeps track of everything that happens in the world of tennis, and he stores that in these two repositories. If you want to ever have like a feel of what the original source data looks like, if you're interested in tennis, this is a very, very rich resource of data. And it doesn't limit itself just to Grand Slams, but really all professional levels of tennis. For this webinar, however, I've already done all the pre-processing, so we can cut straight to the chase. So there's no need to go to these repositories for the webinar now. Okay, well, let's get started. So the first thing we need to do is we're going to load in this pre-processed data. There's a file for the women, which is called WTA, and one for the men, which is called ATP. And with a good old familiar read CSV, we would load that in. But the interesting thing is already it's not working. And why is it not working? Because we have not run the setup chunks where we load the relevant packages. So what I'm going to do is I'm going to go to the run button, and there is an option called run all chunks above, and I will run that. And now if I execute this chunk, which I can do by pressing the play button, but what I prefer is to use keyboard shortcuts. In this case, Command-Shift-Enter if you're on a Mac, or Control-Shift-Enter if you're on Windows. We'll run all the code in both in this chunk. Okay, well, let's have a little look at the data. Here I'm just printing out the first 6 rows of the women's data, and you can see that there's a few columns with information. We have an ID for the tournament, we have a name for the tournament level, and the G indicates Grand Slam. We have tournament dates and who was the winner. There's also a round column, but that's an artifact of my data processing. I used it to figure out which were the final rounds. Okay, now we have to do one final step of data processing, and that is adding a date column to this data. In principle, this data is very clean and it should all be chronologically sorted, but we cannot be absolutely sure about it. And I don't want to go through all the rows of data manually. So I'm just going to be sure and add a date column and then arrange the data by date. It's not so important for the first question, but when we're looking at who won tournaments consecutively, this chronological ordering is very important. So don't forget to run this chunk. Command-Shift-Enter, Control-Shift-Enter, or press the play button. All right, now the data is ready. And our first question is, who won the most Grand Slam tournaments single player? Now, what I'm going to do is, you can see in the learner file, you counted this a couple of times. There's some cells with some empty code, and you're meant to fill this in. I'm going to code it live immediately because people who are not coding along, I don't want you to have to wait. But I will not say anything until I have the answer. So if you want to try it for yourself, just look away from my screen, look on your screen, and see if you can figure this out. What code would you use to get the top 5 winners for each gender separately? Okay, now I've added it to mine. So what I've done, you could have seen this if you looked with me. If not, because there's a row for each tournament, and we have the winner for each tournament, we can simply count how often a winner appears. And then you need to figure out the top 5. Now there's many different ways to do this, but a fairly recent function that I like a lot is called slice max. And what it will do is it will slice out a number of rows that you can, and that number you can define by yourself. And then it will take according to the maximum values, according to a column that you specify. So when we did count winner name, it created a column called N containing the counts. And when I do slice max on N, what it will take is it will take the maximum, the highest scores on this N column. And in this case, I told it take the 5 highest scores. So here's the result. Margaret Court was the won the most, and then it's Serena Williams, and then Steffi Graf, and we can go on. And for the men, it's Rafael Nadal, and then Roger Federer. But no, they're both 20. It's just the luck of having RA as your first name. That Rafael Nadal appears first here. This is interesting. Some people might be surprised because I think these days in the media it's quite common to notice that Serena Williams is widely regarded as the best women tennis player of all time. So Margaret Court is a surprise result. And that I'm going to just skip over this visualization bit because we'll go back to that. And that has something to do with the context of the data that Enrico pointed out to me when we were going through this. And that is something, I'm not a huge tennis person. He pointed out that that was wrong. So we dove into that. And we found out that there is an open era in tennis, and that open era started in 1968. And the reason for that was before then, tennis was for amateurs, but who constituted of an amateur was very hard to enforce. And some people were sponsored, technically not professionals, but were still much better resourced to play good tennis. So it created very, it created an uneven competition. So in the open era, they allowed official professionals to participate so that at least the labeling was correct. And that changed because it meant that some people wouldn't just win everything. So if we run the same code on the data, but we filter that data for it to be larger than 1967, we'll see that we'll get a different result. And now it's Margaret Court is still there because she played before and after 1968, but she has not as many wins anymore as Serena Williams or Steffi Graf. We could do the same for the ATP, which I'll do now. And then we see that for the men, it doesn't really change anything. Now we have a nice top 5. It's obviously very nice to add a visualization of that. Apologies, I think I have a little data problem here. Not quite sure what's going on. There you go. See, typos happen to me all the time too. So here is our top 5 visualized with a nice green of Wimbledon grass. Okay, so we have an answer to our first question. Who are the 5 best tennis players when we're looking at Grand Slams? Now we're going to move on to our second question, and this is a little bit more complicated. So not only are we interested in who won the most Grand Slam tournaments, but are there people who had a winning streak, like people who won many different tournaments in a row? People who are initiated in tennis might be aware that it's quite special if you win all the Grand Slam tournaments in 1 year, and that's why this question here is quite interesting. Like to look at if that was the case, and if not, who had the longest streak in general. But this problem is a bit more complicated. We cannot simply just count winners. We'd have to kind of take into account that they occur in a particular time frame. Because an athlete can win once, and then lose, and then win again. And then these 2 wins cannot count towards the same streak. Again, as Enrico pointed out to me, I think it's Rafael Nadal who wins every year. He wins Roland Garros. So so you can imagine Roger Federer winning all of the Grand Slams except for Roland Garros, and then you would, and then the next year the same would happen again. That would mean that the streak counter would have to start over again for every year, because Rafael Nadal would stick his tennis racket in between the winning streak of Roger Federer. So we need to somehow account for this kind of like timeline and for interruptions in someone's winning streak. And also an athlete can have multiple streaks. So the answer will not be as unambiguous as the previous part. In the previous part, every athlete only appears once, and now it might be that they appear many times. Okay, so here I'm going to demonstrate an approach that we can take. It's a multi-step approach, and we'll do it for the women. After that, you can use this as an exercise to win it do it for the men as well. So the first thing we want to do is we want to be sure that we can compare games in consecutive order. We want to have a feeling of how they. Sorry, I had a little audio problem, but I think it's resolved now. Please interrupt if you cannot hear me anymore.
We can hear you.
Thank you. The trouble with Grand Slams is that they're not evenly spaced in time. The interval between Grand Slams is not equal. So it's much more useful to kind of forget about the dates and create an identifier for each game. And a simple function we use for that is the row number function. The row number function will just assign a new column containing the row number. And that works in this case because if you recall, we've already sorted our data chronologically. So if we now just add a number, then you know that every game will have a unique number that refers to the order in which this game appeared in time. So what we'll do is we'll add a new column. We'll use the mutate function for that. I'll call that column game ID. And then I'll call the function row number to create this. Now let's have a little look. And now you can see that our data starts in 1949 with the Australian Open. And that is game ID 1. And then the next game, and you can look at the dates. The increment in game ID matches the chronological ordering of the game. So now we have an ID for each game. That's our first step. Now, the second thing I want to do, and this comes with the realization that the streaks are individual. Other athletes have nothing to do with a streak except for potentially interrupting them. But whether something is a streak or not is specific to the individual. So the data processing I'm going to do is individual as well. So what I'm going to do is I'm going to group my data by athlete, and the column that refers to athlete is called winner name. So what I've done is I added the group by function and I've grouped my data by winner name. Now, if you want to know if your data is grouped or not, what you simply need to do is go to the console, print out the data, and the top row will tell you whether the data is grouped or not. Because if I now, for example, if I ungroup, that information is gone. So now anything I do will apply to all, will not distinguish between athletes, but once I've grouped my data, it will. Now let's have another look at the data. In this case, I'm just going to arrange. It was already arranged by date, and now we're also arranged by athletes, so that we get a bit of a feeling of how athletes are doing in general, just to know what we are working towards. So this is a snapshot of our data, beginning with all the games that Althea Gibson has played in chronological order, and then all the games that Amélie Mauresmo has played in chronological order, and so on. And what we can see is that Althea Gibson won a Grand Slam tournament in 1956 in May. It was the 30th Grand Slam tournament in our data. And the next Grand Slam that she won was in 1957 in June 24. And we can already see that these two were not consecutive. There were 4 Grand Slam tournaments in between because the game ID jumps from 30 to 35. So whoever won game 31 and 32 and 33 and 34, those are not Althea Gibson. But here it gets interesting because the next row, she won another Grand Slam in 1957, and this game ID is 36. So you could see, okay, Althea Gibson has 2 games in a row. And somehow we want our code to kind of pick up on this, that the first title is not part of the same streak as the second and the third titles. So that's what we're gonna do here. Now, one way we could approach this is by comparing our current ID to the previous ID, and we can do this quite simply. There are window functions depending on where you are in Foundation of Data Science. You might have already come across them, and window functions allow you to look ahead or behind in your data. So depending on the row you are, you can look at rows ahead or rows behind, and in this case, that is quite useful. Let me print out the data one more time, then we have a bit of a visual impression. So if I, for example, on the second row, and I was able to look back, then I could establish that the game ID on this row is 5 apart from the game ID on the first row. Now, the function we'll use for that is called lag. Which will look up in the data and show us the value of the previous row. So I'm going to add another column. So I'm using mutate again. I'm going to call this column previous game. And it will be the lag of the current game ID. Now I'm going to add another parameter. It's called default. And what this does is it basically, you can imagine that we cannot keep looking back forever, because there will be a time that there is a first game that an athlete won. So then the previous game before that doesn't exist, so it's a missing value. The problem is that for the computations we're going to do in the next steps, a missing value is going to mess our computations up. So I need to give it a valid number, but it shouldn't be a number that confuses our computations. I've chosen here -99, and why that is a sensible choice is something that makes much more sense for me to explain a little bit later. But you can right for now, you can just simply copy that. So if I run this code, and we'll examine data again, you can see we have the same data, but we've added a column previous game. And now you can see that on the first row, the previous game is -99, related to that default that I specified. There was no previous game, so -99 is filled in. On the second row, the previous game is 30, and that's correct, but because that's the game ID from the previous row, and we can go on. On the third row, the previous game is 35. So this is how lag works. So it's kind of like helps us to look back in time. We can also see the effect of that we have grouped our data here, because when we get to the next athlete, the previous game is not 40. Instead, it's -99 again, because we did group by athlete. It will not consider any data from the other athletes in this case. So we'll start over again. I can show you that quickly, just to get a good feel. If I just ungroup this data and do it again, you can see now that the data of, but this is interesting. This is because we arranged our data set, but that's fine. You can see that now the previous game is no longer -99, it's 228. And that's actually because when I did this lag, I hadn't arranged the data yet by winner name. So whoever was there before, that's the game ID that came from. But you can see that it's no longer -99, but it just took the game ID of the row that was in front of it when we ran the lag. Now, if you did this along with me, then one thing we need to do now is repair this little demonstration. So go to line 224, group the data again. So otherwise your next steps will get messed up. And we also need to remove that ungroup and calculate the lag again. But that's only necessary if you did this ungrouping exercise with me. Okay. So now it's all good again. So Amélie Mauresmo is again the previous game. The first previous game is -99. Okay. So now we have a feeling in our data. What was the current game? What's the previous game? And now we can start thinking about, okay, how can we use this to identify streaks? Well, one way of doing that would be to figure out for each row whether this game was the start of something new. So that we have a marker for the beginning of each streak. And this is where the values of this lag of the game ID and the lag come in. But what we can do is we can evaluate whether the current game ID is one apart from the previous game ID. If it is, that's not the start of something new. But if it isn't, and then it is the start of something new. And I'm sorry for all the negatives here. It makes it a bit messy, but that's the way this logic works, I'm afraid. But what we want to know is we're going to figure out if the difference between the game idea and the previous game idea is not 1. If it's not 1, then it's the start of something new, and that's what we kind of are interested in here. So I'm going to call this variable streak begin. Note that I put it in mutate again here. And I'm going to compare the current game ID with the previous game ID. So I subtract the previous game from the current game. And I say, if this isn't 1, so I first type an exclamation mark and then an equal sign. If it isn't 1, then I want you to tell me that. Do you give me a true? This is a logical expression. If this expression holds, it will return true. If this expression doesn't hold, it will return false. One more time here, because my formatting transforms this into a mathematical symbol. But if you're typing this, it's an exclamation mark and then an equal sign. Now, if I run this, we will see. Let's have a look at the data. So we already established that that first row was a streak on its own, and the streak begin is true. The second row we established was not in a consecutive order with the first row, and we can see that because the streak begin again is true. The third row, however, was in a row was in a sequence with the second one, and that's why this one says false, because 36 minus 35 is equal to 1. So in this case, it returns false. So now we have like a marker for each beginning of a streak. Now, maybe, yeah, if you struggle with the logic here, then what I can say is that in the answers, I'm a bit more elaborate in describing it, so you could later use that as a reference point to read it. This is also why I chose minus 99, because minus 99 is a value that if I subtract if I subtract minus 99 from any of the game ideas, it will never return 1. So it will always identify as the start of a streak, which it should do because it's the first game an athlete won. So that's why I chose minus 99. I could have chosen minus 1,000,000 or anything that really doesn't lead to a difference of 1 with the current game ID. Okay. Now, so we have something that marks the beginning of each streak. Now, that's cool. I'm going to take a little step back, a little intermezzo, because the next thing we're going to need is a mathematical function called a cumulative sum. But before we use that, I want to explain what a cumulative sum is for those of you who are unfamiliar with it. So a cumulative sum, let's demonstrate. We have a vector that contains the values 1, 2, 3, and 4. If I run the cumulative sum on that in R, that is called the cum sum, I get another vector that has the same length as the original vector. It has 4 elements. The first element is the sum of the first element of the original vector. The second element is the sum of the first 2 elements of the original vector. The third element is the sum of the first 3 of the original vector, and the fourth, the sum of the first 4. So we get 1 plus 2 makes 3, 1 plus 2 plus 3 makes 6, sorry. 1 plus 2 plus 3 plus 4 makes 10. This is the cumulative sum because it accumulates over the elements of a vector. That in itself is not so useful for us, but it becomes useful when we consider that the trues and falses that we have in our streak begin column are represented by ones and zeros in R. Let me show you that. So here's another vector. It's 0, 1, 0, 0, 1. If I run the cumulative sum, what I get is 0, 0 plus 1 is 1. 0 plus 1 plus 0 is also 1. 0 plus 1 plus 0 is also 1. 0 plus 1 plus 0 plus 0 plus 1 makes 2. And if I replace those zeros and ones with falses and trues, I will get the same result. So you can see that the the false acts as a 0 and the 1 acts as a true. That has to do with the internal representation of these logical values in the computer. The other thing to observe here is that as soon as a true appears in this vector, the cumulative sum will increment. It will increase by 1. So as soon as we have this vector, and as long as it's false, it will be 0. But as soon as it hits true, it will go up by 1. And then after that, it remains false for another 2 elements. And you can see that that value doesn't change because it keeps adding 0 to it. So the value stays the same until it hits the other true, and then it turns into 2. And this is where it gets interesting, because if we look at our data, our streak begin is indicated with a true. So if you were to run a cumulative sum on that, what would happen is here it would be 1, here it would be 2. Adding a false to that would not change it, so it would remain 2. Adding another true, so another streak, would be 3. Adding another false, again, it wouldn't change it. Now what you get is a number that identifies each streak uniquely, because the number will only change when we arrive at the next streak. Let's move on and show you that. So if we run the cumulative sum on streak begin, what we'll get is a number that increments with every new streak. So I'm going to add it here. I'll use mutate. I'll call it streak ID because that number we will use as an identifier. Cumulative sum on streak begin. We'll run it and let's admire our result. What you can see now is here's the true, here's the streak ID 1, here's the true, streak ID 2, here's a false, streak ID 2, true, 3, false, 3. And for this new athlete, it all starts over again because remember our data is grouped. So what we now have is a unique number for each streak. It's not completely unique, right? Because we have many ones, but they're all associated with different athletes. And because our data is grouped by athletes, that's fine. But for each athlete, we have a unique identifier for each single streak. And now we're back in familiar territory, because the only thing we now have to do is count the occurrences of each of these values. How often does a 1 appear? And then we get an indicator, and that will then tell us how long that particular streak was. So what I'm going to do here is I'm just going to do a simple count streak ID. I'm also going to sort this so that I get like the top. And now we can admire our result. And there you go. Here we have Margaret Court, who once won 10 Grand Slams in a row. Apologies, not 10. That's the streak ID. She won 6 Grand Slams in a row. Martina Navratilova also. And then we have another one, Maureen Connolly. And then we get Steffi Graf, who won 5 in a row once. Then Serena Williams, 4. Another times she had a 4. And then Steffi Graf had a 4. So we recall that we didn't do this filtering on the open era here. So the results might be slightly different if we had filtered this data on 1968 onwards. But this is your result. And we can also see that Steffi Graf was active in the 90s, so that was definitely in the open era. So when we're looking at the person who won the most Grand Slams, Serena Williams is uncontestably the winner, but Steffi Graf comes in quite close if you look at like the streaks, because she apparently won 5 in a row. That means that she, for 1 year, she won all the Grand Slams. And it's also interesting because it will shows that if you ask different questions to answer the same main question, you might get slightly different results. Let's have a little look. Let's examine some of, sorry, I'm just going to go back quickly. One of the streaks, for example, that Serena Williams did was streak number 13, where she won 4 in a row. And because I still have the original data, we can have a little look at what that looked like. So, and here, this is interesting. The first entry is not actually Serena Williams. And this is again, because we have this group data, right? So, so multiple people had the same streak ID, but because the data was grouped, the count was able to separate. We're in this case only interested in Serena Williams. So this streak of 4 that Serena Williams did was started in 2014 with the US Open and ended in 2015 with Wimbledon. That year she didn't win the US Open, so her streak ended. Now let's have a look at that one from Steffi Graf. So that one is streak ID 2. I'm going to be a bit more precise this time. I'm going to say, okay, I want streak ID 2, and I also want the winner name being Steffi Graf. Is that how we spell it? Yes. And now let's run this code again. Interesting.
You missed the double equal.
Ah, it's a classic mistake for me. Thank you. And there you go. So you can see that Steffi Graf one time went full circle. She won the Australian Open in '88 and the French, being Roland Garros. Then Wimbledon, US Open, and again this Australian Open, which is a pretty impressive feat. So that kind of answers our question. You could make interesting visualizations with this. One thing I've done, it was really, unfortunately, it was beyond the scope of this particular webinar to kind of show you how to do it. But in fact, I put it on just before this Learner Lab. I put it on the internet, so you could find it here. There you go. I'll send you the link. Using this data, you could kind of create nice. Okay, that's not going to work very well. It should also be here. There you go. So this is a timeline visualization that you probably want to look at in a zoomed in fashion that shows when women athletes won Grand Slams in the 21st century. And you can also see when they won streaks. So it makes for kind of like nice sports statistics data. There's a little bit of work in this one, but the code is all here. I have an intention to write it all up in a blog so that there's some kind of tutorial, but it's something I haven't gotten around to yet. Here, because it's the 21st century, we cannot see Steffi Graf because she wasn't active anymore in the 21st century. So here it's undeniably Serena Williams of our generation. She is the best tennis player. And now it's up to you to do it for the men. Is it Roger Federer, or is it Rafael Nadal, or maybe even Novak Djokovic? Okay, so that's it from for the active part. Maybe we can hand over to some questions. Yeah.
So some questions were asked and some of them were answered. There was one which was very relevant. Some people were probably not able to use the slice max function because it's actually a new function from
Yes.
the tidyverse package. So the former version of slice_max was top_n. And then that function was superseded. And if you install the package again, you will get both slice max and top_n. So I apologize for that, for the people who were not able to use slice max directly.
Thank you for that.
There was also an interesting remark about the grouping. When you did the grouping by winner name,
Yeah.
One person asked, should not we also include the winner ID? Because what happens if we have two tennis players with the same name, who are not exactly the same ones? So that was a very relevant remark. It's true that it will be safer to use both the winner ID on the winner name. But here we know, because Bobby is a very well-known specialist of tennis, that there are no other players, so there are not two players with different names on with same name on different IDs. So that's why Bobby was able to use.
Absolutely right. And actually, this is very bad practice for me, because this is what I often say in one-on-ones: use IDs when they are available. So because they're unique, they're supposed to be, at least. Yeah.
And I don't see other questions, but if other people would like to ask additional questions, either on the chat or also unmute themselves. So, I'm a tennis player in Switzerland, so I don't need any data processing to know that BZA.
Yeah.
But be careful, there are some Spanish guys and probably people from Serbia, and this is a very interesting question. But to be honest, just repeat it and apply it to men. It's exactly the same instructions, except that the input data is different. So you will probably get an objective answer according to the different criteria you could use. But we kindly invite you to repeat that exercise using the men data, and then we'll see if Swiss people can actually believe in what they or confirm in what they believe.
Yes. Yeah. Exactly. And they're all still active, right? I mean, it's
absolutely.
And Novak is slightly younger, maybe 2 years or something.
A bit younger, yes, Djokovic.
Yeah, but it's it's what. Okay, we have another question.
Yes, from Sanda. So I'm not sure if they are able to unmute their mic. If you are able to do it, Sanda, please do it. Unmute your mic and you can actually ask your question. But then no. They cannot unmute. Okay, would it be possible to let the participants unmute themselves?
Yeah. I think now you might be able to ask your questions on the. No? Okay. I think you might be able to ask your question now. But I can read a comment on the visualization program. Do you mean you want to know a little bit more about what you learned there?
The question from Sanda.
Oh, okay. No, I think I understand. If I understand correctly, I didn't post yet the link to the visualization, and that's correct. So I'll do that now. So the GitHub to the visualization link is now in the chat if you want it.
There was also a remark from Laurent. Could the webinar invitation in the future specify the platform that will be used? And then he says, I've never seen R before, so I was a bit lost. We use Python in the ML course. So what was the question here? The platform that will be used. Yeah, so probably next time, you're right, we will specify explicitly that R will be the environment that will be used. I think it was not mentioned it was about. Anyway, you were not. I think the idea for those of you who are not familiar at all with R is just to see how it works. For those of you who already worked with R, obviously we gave the possibility to work on try to do the same thing in parallel. But you are right. I think it's not a bad idea to specify that the hands-on will be done using the R language, or the Python language if it is another webinar. Okay. I can hear some noise. Probably somebody is trying to ask a question. So Kanyao, you wanted to unmute and ask a question. Are you able to do it now?
Can you hear me now?
Yeah. Yes, we can hear you.
Oh, yes. Just curious to ask, thanks, Bobby, for the very great presentation. Curious to ask, where is the data from? Is that a script from the website, or where did you find the data that you analyzed today?
I can give you a quick demonstration. So I didn't scrape anything. Actually, Enrico came across it. Credit where credit's due. If I am sharing my screen, so it's a person called Jeff Sackman, and he is very he keeps track of all this tennis. I don't know if it's automated or if he does it manually, but every time there's a new game, he adds the data to it. So this is the WTA repository that has matches from all the way from 1948, qualifications, rankings. You can see it goes all the way to 2021, and it's been updated yesterday. No, not yesterday, through the 22nd of March. So that is the beginning of this week. And what I did is I forked this repository, and then I read in all the data myself, and I filtered so that I only kept the Grand Slam finals, because that's what I was interested in. But you could do anything with this data. The reason I didn't put all the data in my repository is it's a lot of data, and we only use a tiny amount of it, so it's not very efficient to use everything. And you're free to use this data. The only thing is that such open data often comes with certain limitations on the license. Like you can't put this in a paid product or something like that. This data, you have to kind of. This is also why all the resources I did are all publicly available, so that everyone can benefit from it. But that's not necessarily typical for this data. That's a general thing. If you're using open data, it's useful to check what license it appears under. But it's on a GitHub repository. It's actually mentioned in the repository that I pointed you to, so you can find the link in your learner document if you want to explore it a bit more.
Okay, thank you very much.
Then there was a nice comment from Anne-Sylvie saying, generally speaking, independently of R or not, it was very interesting to see the logic you used to solve the consecutively problem. Thank you. And that was the whole point here. Obviously, we are using R, but I think what Bobby just explained is a kind of algorithm to solve this question of consecutive games, which seems a very simple question, but which is quite a difficult one in terms of a computer science problem. So the logic that was presented here by Bobby could be easily translated in Python or in any other language. Which is important here is the rationale. And as Bobby mentioned at the beginning, that was one of the main purposes of doing this webinar, focusing on that particular question, because we know it's a very hard question and probably the most difficult question that you have to address in the Foundation of Data Science course. And then a lot of congratulations message from the participants addressed to Bobby. So yes, and I agree with them. It was a very nice presentation. Congratulations for that, very clear and hopefully very helpful, but I'm sure it was.
Yeah.
Great. Well, if we have no other questions, then I just like to let you all know that we'll be sending out an email in the next couple of days with the recording of the session, as well as details about our next Learning Lab webinar in April, which is focusing on how to market your digital skills on the job market. So you'll get more details about that soon. And then you're also welcome to invite colleagues or friends to our learning labs. Just send us an email at learner.support@extensionschool.ch. And equally, if you have any feedback or you have suggestions for future Learning Lab webinars, or you didn't have any questions answered today that you'd still like to have answered, please just send us an email at the same address. Thank you very much, everyone, for attending.
Thank you.
Thank you. Bye-bye.
Bye-bye.